In this video, what I'm trying to do is, a lot of people think that Albert Einstein's theory on relativity is relevant. It's a concrete theory, and it's not. And it seems people would rather believe the unbelievable than the believable. In any essence, in this video, I have two diagrams that I'll be following. And the first one is the actual event of traveling at the speed of light. The second one is Einstein's theory about light. That light is a constant. Nothing can travel faster than light. And if you did approach light, how things would be. Planets would seem like they're closer together when they're actually not. And to do such, you would have to bend space with it to make it happen. And all these are eluding the facts. And the facts are mathematical. I hate to say, they're mathematical. You do the math, and based on the event, rather than the event based on the facts, you get a completely different outcome. And that's what my video is about. Besides that, once you discover his illusion, his cosmological blunder, they call it, you'll understand more about how space actually works. And in essence, my videos show a secondary theory of what it really is. Because there was another professor who actually took Einstein's to his telescope and showed him the difference. And that's why it's been noted that Einstein's theory is a blunder. That the universe, which is gravity, space, as you will, travels faster than light. It's not, there's no connection between space and time. Time is an instrument we use to measure things, not to bend space, not to time travel. And the essence of time travel, you got a little teeny ship, the size of an ant in space, in the middle of nowhere, let's say between two galaxies. And that little ship's going to do any changes on the galaxies? No, is it? It's like a car without brakes. It's just going to go bam. It's gone. It's literally impossible. So he invented. In the second diagram, Einstein's diagram, where I show his illusion, I also show why his illusion is he took space, gravity, Earth gravity. When you drive a car and you take your foot off the pedal, it don't keep going, it slows down. And that's a force acting on a force. Attraction acting on acceleration. Well, he took that same force and put it in space. And space, as we know, is different. Isaac Newton, his universal gravity theory. I don't think they knew it at that time, much less we knew it, because we hadn't been in space yet, But only knew that things travel pretty fast in space, falling stars, stuff like that. But Isaac Newton, what he did is he took, okay, if we have a 50% attraction to an acceleration force, then in space, we could say that there's nothing in space, So the attraction's not there, so our mass would keep on moving, you know. And he didn't say it would move at the speed of light, but he did. What he did was measure how things fell and how fast they fell. And he didn't know the reason why. And relevant to that, I don't even think Einstein knew why. It was the difference. But in my books, I show why it happens, how fast we can go. My diagrams, I show, you know, the difference between my Edwin Hubble's and my theory is I went a little further and evaluated how actually fast you could travel. I found a mathematical way of deciphering how fast you could travel under those circumstances, you know, in the same way that Newton discovered. And Einstein's theory is kind of like in the middle, but it doesn't take, it takes you to Disneyland, you know. It takes you to things that eluded his mind, you know. E equals mc squared. Can we travel at the speed of light on Earth? We got particles that go on an accelerator that travels the speed of light, but can we make an actual ship do that? And that's only once around, you know. Relevant to its size. Just think of the size of a ship trying to travel at the speed of light in the Earth's atmosphere. You're talking about going around the planet 1,000 times before it even reaches light speed. So it's kind of like out of the question. There has to be something more deeper. I'm not saying time travel isn't impossible. I have an idea of how time travel might work, but its possibilities are way beyond our thinking today. You know, Einstein took time travel and says, "Well, time goes back. You can't reverse time. You can see. This is why you can't reverse time. Can you reverse a planet? Can you reverse Jupiter? Can you reverse, make it go backwards? Neptune, you know." And that's what it would take just to slow drag a planet into being able to travel into the past. You have to make it go backwards. Or just because you go on light speed doesn't mean that that's even slower than traveling into the past. And that planet's gonna, it's like you're not moving. You know you are at the speed of light. But eventually it's like not moving. Come on, man. Time works the way it does. Tick tock, and I don't care where you're at. You know. Now the seconds on, you know, or let's say the days and hours on one planet may be different than the other one. You know, it may take only 24 hours for a planet to make a rotation, a single rotation, which we would call a single day. But that doesn't change Earth's idea of a single day. We got 365 of them, you know. So the relevancy between these theories, including inflation and including time travel, it's just not possible. Now, Einstein even gave a good idea about gravity in space, how that might work. Irrelevant. But the way he explains gravity is all the planets are lined up are lined up in a straight line together. Not in a straight line, but they're all over the place, but they're all on, it's like 20,000 boats on top of the ocean. You know, they're all on the same ocean. And they sink in that ocean. A bigger boat would sink more than a smaller boat, you know, like a rowboat, you know. And that's kind of like Einstein's theory. And the flat space idea comes from, space has to be on the bottom of something. And for the boats to be on the top of it. And vaguely, that's how it works, but yet he turns around and says that we are inside this gravity. I think we are outside the gravity, and the gravity that holds up all the planets is more dense. That's why it keeps us up. Or, yeah, that's how it would be. I was going to say that the fabric of which all our boats on the ocean, which we're calling space, is more dense than the space over it. You know, without energy, things wouldn't cling to the Earth's surface. They'd fly away. There's only no wings, nothing. There's no gravity, right? So what would that mean? There's a theory, it's called a hollow theory. It means that it's there, but it has no energy. Energy is the key to everything. Energy, let's say this planet's here, and it has energy. So everything like us, we walk around on this planet. Bam, we walk, we jump, we do all these things, and we stay on the planet. But then you go on, like on the moon, and you, instead of jumping 3 feet, you jump 15 feet. You know, there's a difference. So let's say we're back on Earth, and there's no gravity. So that means there's no gravity in whatever makes gravity, planetary gravity, in the planet. If it didn't exist, things would just do what they want. They would just not, they would just, I mean, not, you can't even call it fly away, they would just float away. Nothing would cling to this planet that we have. And the thing is, in space there is no energy, because there's no energy in the space for it to cling to. So what I'm saying is that flat space theory, like I says, you know, you got 1,000 boats on top of the ocean, and all the boats represent, let's say, galaxies and stuff, but they're sitting on the fabric of space, which is the surface. So now it's a surface. You got to remember this. It's a surface, but what's under that surface? It's a more dense type of space than exists above it, because we can jump and we just float in space. We're weightless. That means there's no energy. So there's a big difference between space and Earth relevant to gravity. And Einstein's theories take us into 2 or 3 different dilemmas, because there's 2 or 3 ways to look at this. You know, it's like Newton's theory. There's well, we'll look at gravity here, and we'll look at this other thing about no gravity. But yet he didn't know that there was no gravity, there was a vacuum up there. But he assumed by observations, you know, falling stars. But at that time they were looking at falling stars. But what did Einstein learn? Einstein didn't look at no telescopes. No. He did all his stuff in the patent shop. But anyways, I wanted to present these 2 illustrations, and how simple one is between the other one, how difficult Einstein made things by explaining what he was talking about and what actually is. You know. They say he didn't know much about math, you know. anyways, my name is Rod Kowicki, and I hope you like physics. Thank you very much.